So I'll do my best to get through these and explain them. But admittedly, I might do some um, part of this. I might end up just doing as a setting them up, but not finishing them. Okay. So trying to get this so it's organized to the point where you can see kind of everything. And I'll do my best to set them up at least, and especially the ones that involve a calculator like this one here. So let f of x, you get this particular solution, you get this differential equation. Again, that just means a derivative. You get that initial condition, and they want to know, okay, what's the value of f of -2? So if you have e to the y dy is equal to e to the x minus 1 dx, that's separating the variables. That gets all the y stuff on one side and the x stuff on the other side. So if you integrate the left side and you integrate the right side, this side is e to the y, the other side is e to the x minus x plus c. And now we use the 0.10. So we've got e to the 0 is equal to e to the first minus 1 plus c. So c is equal to 1 minus e to the first. So there's c. And that's because e to the 0 is just 1. Sorry, e to the 0 is 1. So that should be 2. Because you'd add 1 to both sides and then subtract e to the first. So there's c. So what you have is you have e to the y equals e to the x minus x plus 2 minus e. So if you take the natural log of both sides, oh, I forgot an x in there, didn't I? So minus x plus 2 minus e, and then just put in -2 and use your calculator. So that's the way I would do that one. Put in -2, use your calculator to get it, and you should get the answer for that one. So question 2. So question 2 says the rate of change of the volume. So if I were going to write that out, that's dV dt. Is leaking out from a tank. So since it's leaking, I'm going to say it's got to be negative because it's leaking, is proportional to the cube of the volume. So it's proportional to the cube of the volume. So some value k times the volume cubed. That would be the cube of the volume. So hopefully, if I click on this, that's that one, right? I mean, this right here is called a constant of proportionality. And it's the only one that has the volume cubed. And I mean, this one does too, but because this one is not negative, that can't be the right one because, that part that says leaking right here, that's a really important piece. So that's why that second one's the answer. So let's go to this one. Hard-boiled egg removed on a table and set to cool. The rate of the egg's temperature, the rate of change of the egg's temperature. So 3, the rate of change of the egg's temperature, which is T. T with respect to time, T is proportional to the difference between the egg's temperature in degrees Fahrenheit and the room, which is 75 degrees. So T minus difference 75. Again, you need a constant of proportionality. So when you look at what what that is there. Hopefully there's the big T there, there's the constant, there's the difference. That's what we're looking at right there. So that's the answer. Okay, again, that's a constant of proportionality. You got this time T and then the 75. All right, let's go to number 4. Number 4, a total of n students at school. The number of students that have seen the television program increases at a rate proportional to the product of the number of students who have seen the program and the number of students who have not seen the program. If S denotes the number of students who have seen the program and T denotes the students, which of the following differential equations could be used to model this situation? So when you think about it, okay, so you got ds, dt, and it says, and so you're going to have some constant proportionality. Now, it doesn't really matter, right? Because there's a constant in all of those. So now you got to figure out what the other one is. You got n is the total number of students at school, and it increases at a rate proportional to the product of the number of students who have seen the program. So that's S. And the number of students who have not seen the program. So if S has seen the program, then N minus S is going to be not seen. So hopefully that gets me the right answer. And there it is, right there. Okay, so again, you're just writing these equations. This is a pretty, I mean, not a lot of calculus involved with this, with these questions right here. Just knowing how do you interpret things. So on this one, this is a trial and error. Question 5. If I'm doing question 5, my main thing on there, which of the following is a solution to the differential equation? I'm going to use trial and error. And what I mean by that is, if I take A and I look at y prime is equal to 2x. B, y prime is equal to 6x. C, y prime is equal to 15x squared. D, y prime is equal to 21x squared. So what I'm going to do is I'm going to go through and I'm going to just try these. And notice that, if I have this equation, x times y prime minus 3y is equal to 6, I'm going to go through and just check it. So let me look at this first one. Let me just try it and say, okay, well, if this is y, if I have x times 2x, so if I use A, x times 2x, because that's y prime, minus 3 times y, which is this one, x squared plus 2, we're supposed to get 6 out of it. Well, notice what we get on this is we get 2x squared minus 3x squared minus 6 equals 6. And that's, nope, we can't do that because that doesn't work out to be the same. Those don't work out to be equal. And then you try B. And then you try C. And then you try D. And what you'll find out is, I think C is the answer, if I remember right. Let me just check. C is the right answer. So let me show you what happens when you use C. When you use C, you got x times 15x squared minus 3 times 5x cubed minus 2 and equals 6. So this is 15x cubed minus 15x cubed plus 6 equals 6. And I would say, yep, that works. Check, that works. Little trial and error on that one. That's the best you can do on that. I think the same kind of thing goes on this one. Second derivative, right there. These are some of the toughest ones, I think, on AP when they say 1, 2, 3 only, 1 and 2. And the key is just to figure out, well, does one work? So Roman numeral number 1 says if y is equal to 3 sine 2x, that means y prime is going to be 3 sine 2x times 2, or in this case 6 sine 2x. Notice what, not sine, cosine, sorry, this should be cosine. So notice that the next time I do it, y double prime is going to be negative 12 sine 2x. So if we take the derivative, so, oh, I didn't mean to do that. Let me go back to this. Sorry, I hit a bad button there. So if I'm kind of looking at this going, okay, well, what does that get me? Here's what it gets me, is 4 times y minus 12 sine 2x, which is y double prime. Does that equal 0? And the answer is yes. And then you'll check C, Roman numeral number 2. That will work as well, because you definitely need some sort of a generation of a negative. And Roman numeral number 3 does not generate a negative. If you look at it, you need to have this negative generated right there when you take the second derivative. And you're going to get that with the cosine as well. You're going to get that. So that's why you maybe could have guessed your way into 1 and 2 only, but you could just try it and make sure that you understand that the other one works. So now let's look at this one. This one is a little bit trickier, but we have to kind of go through these again using trial and error on this one. So on number 7, I'd probably use trial and error. Now, mind you, you probably only get one of these per exam. So don't think, oh my God, we always have to use trial and error. It's just not true. That it is in this progress check, but not in a normal AP exam. You clearly know that this first one is not true, because why? I mean, if I'm looking at this, I know the answer is going to be this one right here, and I can tell you how I know that in a second. But it's because of the way E works and how you can get things to close out. So I'll show, or to come back around. So the first one is clearly not true, because y prime is 0, y double prime is 0, y triple prime is 0, and so you're not going to get the right thing to work out. Which of the following is not a solution, I guess, is not a solution. So this one will work, actually, because if y equals 10, y prime equals 0, y double prime equals 0, y triple prime equals 0. So 0 plus 4 times 0 equals 0. Just like on the last one, these two are going to work as well, because you generate that negative, positive, negative thing. But watch what happens with this one, or let me show you what happens with the second one, because that's the answer right there. So so A was not the answer. A works. And notice it says not, and that's a real key thing. It's not, because if you didn't read that word not, you might get to A and say, oh, that works, I'll pick A. But that not is important there. So in B, y prime is equal to 4e to the negative 2x times negative 2, or negative 8e to the negative 2x. Y double prime is equal, what we're going to do is multiply by 2, so that's going to be 16e to the negative 2x. And then y triple prime, the negative is going to come back again, because we're going to multiply by negative 2, so negative 32e to the negative 2x. Now let's look at what happens. Let's look at what we have here. Notice that we have y triple prime, negative 32 e to the negative 2x, plus 4 times negative 8 e to the negative 2x equals 0. And that's not true. Notice we have negative 32 minus 32 more equals 0. We need this. We need the negatives to flip in a different way, and that's going to happen with these other two as well. So so the answer to this one is that one. Okay. So let's look at number 8. Number 8 is a really one, and I'm just going to expand this and kind of look at what does this look like. So we got this slope field, and I want you to notice what happens when both x and y are positive. We get negative slopes. So that's going to happen in this one. 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 That negative doesn't help us in that area. But let's look at this quadrant right here. This quadrant right here, when x is positive and y is negative, we end up getting a positive slope. So when x is positive and y is negative, we get a positive slope. That might not be true for this one right here, because if x is 2 and y is only negative 1, we get negative slopes. So we can cross this a out right away. Now let's look back here. Both of them are negative. We get a negative slope. That's not going to be true for this one right here. Both negative getting a negative slope. That doesn't make any sense right here, because we're going to square the negative x, multiply by negative y. We should get positive slopes. So now we got to kind of look and say, well, what's happening as x goes, as these things get bigger? Because we're really down to, I think, the first one and the last one here. And notice that when x is, let me just grab the scoring guidelines and explain how it works. Notice that on here, that when, if you pick like, right here, pick this point right here, negative 2, comma, and this is like 1/2 or something like that, that you get a slope smaller than 1 right here. And that would work out for this one, but wouldn't really work out for this one, because of, just pick a point like right here, call this 1/4, negative 2 comma 1/4, and plug it in, and you get a positive 1/4 here, but you'd get more like 4 for this one, which would be a much steeper slope there. So kind of figure out which ones work, which ones don't work, and do your best. You could have also checked zeros here for x, and seen that you got horizontals, which would have really knocked that one out as well. So let's look at 9. So which of the following is a slope field for this differential equation? Notice that right across here, you're getting, when x and y are the same, you're getting 1 as a slope. Looks like about 1 as a slope here, right across this diagonal. When x and y are the same, you're going to get 1. That's not going to work out for this one. You might also kind of look at, right here, this point right here, which is, take that point right there, and that point looks like it's -1, 0. So if x is equal to -1 and y is equal to 0, we need to get 0 for a slope. Well, if you kind of look at it, that will work with this one and might not work with some of the other ones. So you just have to kind of look at these, and hopefully you did some practice on delta math. But there's a lot of different ways you can do these types of problems. You just have to kind of figure out, well, which one is going to work out, and you got to look at these horizontal slopes here and here and right there. That's the point 0, 1, and 0, 1. You should get 0. Well, you wouldn't get that for this one. You wouldn't get it for this one. Point 0, 1. You wouldn't get that. You wouldn't get a slope of 0. 0, 1. You might get it for this one, but you'd also get it for this one, and then you can kind of keep on going on there. So that's how I would do 9. It may not be the best explanation, but I would do some trial and error on this. So take a look at that one again if you're having trouble with it. So here's another one, just more practice on this and looking at it and going, oh, wow, this like 0, 0 gets you a slope of 0. So you kind of have to just pick some points in here and do it in reverse. You could do it that way. Another way you could do it is you could actually separate the variables on this if you really wanted to. If you're like, well, I like separating the variables, one of the things you could do is you could take a problem like this, just because I know we're going to jump right into some separation of variables once. So on number 10, what you could do is you could say, okay, well, let's see if I could separate these variables. This would be a tough separation of variables, actually. I'm not sure that this one separates very well, so I'm not going to do it that way. But what I guess what I would do is I would just, it'd be much easier if I saw this whole thing on our normal AP exam. You'd see every answer, and you could start ruling some out. This looks like a cubic function. So I guess I would just, keep on ruling things out, and what would happen is you'd see that this is the one that works out, and you could think about, well, in the third quadrant over here, when x is positive and y is negative, I need to have negative slopes, and when x is positive and y is negative, we're going to get negative slopes, but over here I'm going to get positive slopes. Well, they kind of go from positive to negative there, and so it's not the best explanation, but that's kind of what I would try to think about. What's happening is pick some points in here and do a process of elimination is the best way to do that type of problem. But there's more than one way to use a process of elimination on this. If you need more explanation on that, let me know and I'll give you a better explanation. So take something like this. There's actually 2 ways to do this problem. If you're really good at taking derivatives, you could just take the derivative of this thing. You could just go through and differentiate everything in there. But if you didn't want to do the derivative, if you're like, I love this separation of variables thing because it seems easy, I could write cosine 4y dy, this is number 11, is equal to cosine 8x dx. And I can integrate both sides. Now I'm going to have to use u substitution. I'm missing a 1/4 in this one. And I'm missing a 1/8 in this one. Now, if you're like, how did you know you're missing those? Well, pick u to be 4y and pick u to be 8x. They're different u's, but I'll go back and look at them. But so this is 1/4 sine 4y equals 1/8 sine 8x plus c. And you can kind of go through here and go, oh, well, when I look at that one's the factor of 2, I can multiply everything by 8. And if I multiply everything by 8, I would get 2 sine 4y is equal to sine 8x plus 8c. Well, that's just a constant. So if you look at it, my guess when I the scoring guidelines, I'm going to get that for my answer, and that matches up. Let me get this so it's organized a little better for you. That matches up with what I got, and it has a factor of 8 in there that kind of threw one of them off. So you just have to do separation of variables on that. There can be a lot of separation of variables on this last grouping. Take this one when I'm doing the separation of variables on this one, and hopefully, you got a lot of practice on delta math. We have, this is a little easier. This is more a level 1 delta math problem, not like those level 2 ones. Hopefully that's kind of the case in these. But there is my separation of variables. Now integrate the left and integrate the right. So this is number 12. So this is going to be y squared, because it'd be y squared over 2, but I'm going to reduce, is equal to x cubed minus x plus c. Now let's put in this, this 1, 4. So y squared is equal to, or sorry, let's go in and plug this in, and we plug in 4. So 16 is equal to 1 cubed minus 1 plus c. So c is equal to 16, right? And so now if I have this, I got y squared is equal to x cubed minus x plus 16. And you take the square root of both sides. And there's your answer. That's got to be that one right there. The other ones don't make any sense. It is that one right there, and you're done. Take a look at 13. Same idea. You're going to get a lot of practice on this, and hopefully this makes some sense. But with 13, if I separate these variables, I get y squared dy is equal to 2x minus 1 dx. So y cubed over 3 is equal to x squared minus x plus c. The point I got is 0, 3. Plug that in. So I get 3 cubed over 3 is equal to c. So c is equal to 9. So if c is equal to 9, I got y cubed over 3 is equal to x squared minus x plus 9. I multiply both sides by 3. I take the cube root. And now you got to kind of figure out what these are. This one's clearly missing. It's a square root, not a cube root. I don't know what that is. Here's a cube root, but they pulled this 3 out there. That concerns me because that's somebody who doesn't know order of operations on there. And this last one is clearly this, right? I mean, this last one is the cube root of 3x squared minus 3x plus 27. And instead of writing a cube root, it's to the 1/3. So you have to recognize that these are the same answer. And so that's clearly going to be our right answer on that one. Let's look at 14. On 14, same kind of deal on this one, although this one is a little tricky on how do you separate the variables. And I know that on 14, I know that usually I say you got to separate the variables with multiplication and division only, and that is still a true statement. But this one, actually, we really need it to be the differential is equal to everything else. And now I can separate these variables. This is a tricky one. This is one that tends to show up a lot on the AP exam. But what I would do is I would divide by this, and I would multiply by dt, and that's just a 1 over there. So now if I integrate these, u is equal to 10 minus p, so du is equal to -1 dp. So -1 du is equal to dp. And what this one works out to be is a negative natural log of 10 minus p is equal to t plus c, because the integral of 1 dt is just t. Think about differentiating t, you just get 1. So that's the integral. Now, we have to use this 0.04, okay? So we have to use this 0.04, so the natural log of 10 minus 4 is equal to 0 plus c, so c is equal to negative natural log 6, okay? There's some simplification on this one, on how this one is gonna come out. So let me show you what I mean by that. If you take this one, and now I have negative natural log 10 minus p equals t minus the natural log of 6. If I'm doing this on a free response question, I'm going to do the following. I'm going to multiply by -1 and get that. I'm going to use e and get that. I'm going to rearrange some things. I could even say p is equal to 10 minus e natural log 6 minus t. And you kind of look here and you go, well, what the heck? Well, notice there's a 6 here, and I can show you how that simplifies, but notice that there's a negative right here in t, and so the answer is this one right here. The reason it's the answer is you could go through and actually do the simplification on this and write this as e to the natural log of 6 times e to the negative t is equal to p, and this is 6, and then we get the answer because the e and the natural log go out and I get 6. So hopefully you can kind of fudge your way and go, well, I know this is going to be the right one because I need a negative t, and these are the only two with negative t, and why in the heck would you divide by 2 when you got this? And so hopefully you kind of realize that that is the case. Moving on to 15, got a couple more here left. We'll see if we can get through them all. Again, separation of variables. This particular one, let's see. I mean, on some level, one could work backwards on this, but this one is actually a different one. This one is actually, I'm looking at the answers, right? I go, well, what do the answers look like? Here's the answer down here. This is that new old thing. So remember, I'll write it down here, but remember an amount new is equal to the amount old plus the integral from the old to the new of the rate. Well, remember that a derivative is just a rate. So if we want to find some y value, we could take the previous y value plus the integral from the previous x value to a new x value of the rate. And that's clearly this last one down here. It's the only one that really works out to be that way. Here they have a wrong initial condition. Here they did some integral things. And I don't think you can integrate this. You're not going to have the ability to integrate that. You might be able to integrate that with some things, but not this one. So you just kind of have to kind of recognize, well, what are the answers? What form do they want me in? And it uses this stuff we did in the last unit. And you just have to recognize that. This one is tricky, and I'll kind of go through this one again. Um, so value, this one's actually not as bad. I think it's similar to that volume one we had, like the third one in there. Value of a car after T years of the purchase is decreasing function V, where V of T is measured in dollars. The rate of change of the car's value in dollars per year, which is dV dt, is proportional, so that's directly proportional to the car's value. That's really similar to that one we did way back. This one, it's really similar. Question number 3 and question number 16 are almost the same question. They really are. So go back and look at 3 and 16. They're almost the same question. Let's see, 17. 17 is the one that's a little bit tricky, where you have to realize on 17, on number 17, you have to realize that if y equals e to the x, dy dx is equal to e to the x. You have to realize that derivative gets itself. So notice that dy dx is equal to y in that case, right? So if you look at this, there may be a constant in there. So what if I did if I said v is equal to some constant times e to the x, then dv dx is going to be that constant times e to the x. Well, notice that that in that case, dv dx is equal to e to the x, or sorry, is equal to v. Well, the one that is this one. Like, none of these other ones are that thing. This one has an extra little piece here that you don't see. So that's why this answer is the one, because of the nature of how e to the x works. If you need more explanation on that, I'll do my best to kind of help you with it. But these words on here, all this information is not necessarily needed. It's how they get the 400. It's how they get this constant up here, but you don't really need it. What you really need to realize is anything with this equation up here, where the derivative is equal to a constant times the original function, only works with these types of functions. So you just have to recognize that. 18, the amount of bacteria in a petri dish increases at a rate proportional to the amount present. At time t equals 0, the amount of bacteria in the dish is 10 grams. At time t equals 2, the amount of bacteria in the... this is one we really actually didn't cover. And so what I'm going to tell you is similar. The amount of bacteria in the petri dish increases at a rate proportional to the amount present. What that means is the amount in a thing increases at a rate proportional to the amount present. So this is the kind of equation that you have to realize, which means the amount is equal to K times E to the T. I haven't seen a lot of these questions on the last few AP exams, but you have to kind of realize that when they give you this tag right here, that you know it comes from this equation. And then you have to kind of go through and calculate stuff. This is the initial amount. So that in this case is 10. So we have A is equal to 10E, and it's really, there's a, use a different K here. I'm going to use a K up here and use a C here, because there's technically two constants on this one. So I'm going to use a C here and a K here, and I'm sorry about it messing that up on you. So I'm going to do that. Whoops. I keep on hitting the wrong thing and it makes it maximizes it. So this is the equation that you have to realize, that these two equations go together when you have that tagline. So then we know we have this, and we know we have this. And then it says at time t equals 2, the amount of bacteria in the dish is 30 grams. Well, what that means is you got 30 grams when this is 2. And you have to solve for k. So we go, okay, well, 3 is equal to e to the k times 2. So natural log of 3 is equal to 2k. So k is equal to the natural log of 3 divided by 2, just using algebra. Now from there, we're going to plug in 6. And when we plug in 6 to this, we have the equation A is equal to 10e to the natural log of 3 over 2 times t. And now we're just going to plug in 6. And that's a really tricky one, because they're asking you to do this without a calculator, which could be tricky. I wonder how they're asking you to do. So this is a tricky one, honestly. Without a calculator, I've never seen a question like this without a calculator, to be honest with you. So I guess I wouldn't care too much about 18. I haven't seen that on an AP exam in a long time, if ever. Hopefully that helped you. Sorry this video is so long. Tried to go through all of them for you. If you need more explanation on any of these, please just let me know.